Ladies and gentlemen, welcome to another episode of Cosmic Catastrophe exclusively on Rumble, 8 p.m. Mountain Time. I am your host, Diamond, from the Oppenheimer Ranch Project, and joining me today is my lovely co-host and partner, Leah Shaper.
Hello.
Welcome to the show. We've got a couple topics we're going to talk about. One I might spring on you as a surprise, but you might have seen it in the news. And there's a lot of nonsense being spread about it. But the first topic we've talked about many times, almost a half a dozen shows on the AMOC. Is the AMOC shutting down? A lot of people fear-mongering about the AMOC these days. That one person this morning claimed that it may shut down as early as 2 decades from now. The problem with that is all the peer-reviewed research is pointing to it not shutting down whatsoever.
Well, and the other problem is that person pointed to a piece of peer-reviewed literature and claimed that that piece of literature was saying that it was shutting down when that's not what it says at all.
No, and we'll get to all of that in just a minute, and welcome to the show. The second topic that we may discuss are strange radio signals emanating from Antarctica.
Oh, yeah, I've seen that. Yeah.
The funny thing is, when you read any of the articles or any of the information about it, they all conclude that it has something to do with a new type of particle physics we don't understand, not a Nazi alien base under the ice in Antarctica.
Right.
Right. Which makes sense because we don't know much about the universe.
No, it turns out we know very little.
But the most likely place, there is a peer-reviewed paper I went over that just came out maybe within a year showing that cosmic rays are coming out of Antarctica.
Yeah.
Yeah. Literally beaming out of Antarctica, just like up in the North Pole.
Beaming in or out?
Out.
Oh, that's interesting. I mean, the in I get, but the out I don't.
Well, that's obviously has something to do with these strange signals they don't understand.
Yeah.
Right.
And everything that we don't understand, even though we claim that we know a lot.
Okay. I got to present. All right, let's get to. Can you see the screen?
Yes.
Is a monster web of ocean currents headed for collapse? And the monster web of ocean currents they're talking about is the Atlantic Meridional Overturning Circulation, the AMOC, which part of it, one of those ocean currents we call the Gulf Stream, the one that's off the east coast of the U.S. What I find fascinating, take a look at this picture here of this icebreaker in the Greenland Sea. What do you notice about the ice?
It's pretty continuous. I mean, it's in chunks, but
yeah, don't they? This is called pancake ice. Don't they look like little pancakes?
Yeah.
So the way this forms, pancake ice, is in, let me see here. Pancake ice is a form of sea ice that consists of round pieces of ice with diameters from a foot to 10 feet in thickness up to 4 inches. And it's a result of wave action. So in areas where there's high wave action, you get pancake ice. And the Greenland Sea is notorious for wave action.
That random sort of triangular piece there.
That's like an iceberg that floated in here.
Yeah.
But through time, it will get worn down into a pancake.
Sure.
Yeah. That's interesting.
Yeah.
So this article isn't claiming the AMOC is shutting down. What it's talking about is new research that's happened that began about a year ago in the Greenland Sea. And they are collecting crucial data on the AMOC.
Yeah. This is really important because, like we've typically only been measuring a small piece of the AMOC, the Florida current, which is just one little area, right? In reality, the AMOC covers such a huge area that if you want to understand what's going on with the AMOC as a whole, you really need to do a lot more investigation of specific areas, in my opinion.
Yeah, I agree. Now let's talk about what we already know. a paper coming out July 2nd, 2024, Atlantic overturning inferred from air-sea heat fluxes indicates no decline since the 1960s. So in this paper, the Atlantic Meridional Overturning Circulation, or AMOC, is showing no decline for 60 years.
Yeah. And this is I didn't read this thoroughly, but because this is based on CIMP6, this is not measuring one area, correct?
They're using the heat fluxes where this current is, that all the data sets available. Remember, we just talked about those crazy acronyms?
Yeah.
So they probably just collect all of the thermal data and look for a trend. And when they did the modeling, they found no trend.
Yeah.
Yeah. So that's the first piece of evidence that the AMOC is not shutting down.
Mm-hmm.
Then we got this paper, September 5th of 2024. And we talked about this in a show.
Mm-hmm.
The Florida current transport observations reveal 4 decades of steady state. And so this is a part of the AMOC down near Florida.
Yeah.
So what we have is evidence that the southern part of the system is not changing.
Yeah.
And this system, the AMOC, is like a conveyor belt, if you would, right? So if one section of it has been stable for decades, you would assume that the entire system is stable.
Well, I don't know. I'm not sure that assumption is true.
Well, think of it this way. If like near Florida is the beginning of this current where it loops around,
mm-hmm.
like it goes all the way up into the Arctic and falls back down into the abyss and reverses direction down the East Coast and comes back up near Florida and starts moving up the East Coast again. Mm-hmm. So what's coming in and what's leaving is happening at the same rate.
Mm-hmm.
And so what's coming in represents what's falling down in the northern part. Right?
Yeah, I guess I was just thinking that, like, especially like in a warmer latitude, it seems like the current could be relatively stable, while in a northern area, maybe just only in the northern area, it could be kind of out of whack, but sort of recover by the time it gets south.
Yeah.
You know? But
again,
I also...
Go ahead.
Sorry. Go ahead. I'm getting off track.
I was going to say, again, another paper that's claiming that there's no change here.
Right. And the critical piece of this paper is they essentially made a giant correction to data that other people have been looking at, right? So there was a piece of the data in this paper from, I think it was 2000 to 2023, that appeared to show a slowing of the AMOC. But it turns out that was a result, it was an instrumentation problem, and combined with changes in the magnetic field of Earth that were not accounted for. So once you account for changes in the magnetic field of Earth and then recalibrate the data shows there's no declining trend.
And it's interesting that it's the change in the magnetic field of Earth.
Yeah. Well, because the magnetic field of Earth was affecting this current was being measured using voltage with a cable, undersea cable.
Right.
And so the magnetic field was messing with the voltage measurement.
And
rather the voltage measurement did not account for the change in the magnetic field. That would be the more accurate way of saying it.
And so the Washington Post, shortly after this paper was published this article: a key ocean current is holding strong despite a predicted slowdown.
Yeah.
Now, my question is, why does everyone want the day after tomorrow to come?
Right.
Because in the initial article, what they conclude is if this AMOC does shut down, temperatures in Western Europe could drop 15 degrees C.
Right.
Sending all of Europe into an ice age.
I mean, the AMOC is the only thing keeping Northwestern Europe relatively warm.
And imagine how cold Scandinavia will get. Like,
yeah,
there are millions of people living up here.
Right.
Denmark is usually very balmy. and it's way up there because it's surrounded by water. But if this AMOC shuts down, no more warm waters going up there.
Right. I mean, it makes it very clear how this is involved in ice ages. And, okay, just because it's not that there's no evidence that it's slowing down now, essentially, that doesn't mean that it won't. We've only been looking at this AMOC current for the last 6 decades, which is a blip in the grand scheme of things. So,
but I think with this new Greenland data and whatever subsequent peer-reviewed literature comes out from it, we will, if they show no change up in the north part, then we can conclude that the AMOC is quite safe for now.
For now, right?
Yeah.
Yes, agreed. It is very frustrating that there are particular people who are claiming that these papers indicate a slowing of the AMOC and blah, 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 because when you say something like that, you're counting on your audience to not go and read the papers for themselves, and you're spouting bullshit. And that's really frustrating. It's infuriating, actually, because you're being a liar and a grifter. And I'm sure you know who you are. It's disgusting.
All right. So the AMOC is probably, based on what we know now, not shutting down. It's been at steady state for 40 or 60 years in the southern portion. And now we're going to get a plethora of data from the Greenland Sea. And you can see here the trek that boat took back and forth from Svalbard to Iceland and back again. And with that data, we're going to find out if any portion of the AMOC is anything other than stable.
Yeah.
Now, how are they going to conclude that based on only one data set on one trip?
Right. Right. I mean, again, we haven't studied this long enough and we don't have enough information.
Yeah, that's the problem.
Yeah. And the other thing is that, we do have evidence that the AMOC has shut down in the past. And we're probably not seeing it right now. Like, if I'm thinking about, the cyclical temperature graph that we've looked at thousands of times, where we get to this peak of high temperature and then it just suddenly drops off.
Yeah.
So I would imagine that we don't really see a slowdown in the AMOC until we start coming down that temperature slope.
Yeah. And it would appear based on let me see if I can pull this up. Good data. And this is going to be ice core data. I don't like that data set, but let's see what this looks like. It's huge. Okay, here's the Epica data. And over here at 0 on the right side is our current interstadial. But what it appears like is that the AMOC shuts down for 80,000 years at a time.
Yeah.
So once the AMOC shuts down, you get no more of these warming circulations, keeping the Arctic somewhat warm or the northern latitudes somewhat warm, and you get a perpetual ice age.
Yeah. I keep wondering why the Neanderthals were moving into Europe during the Ice Age. I keep wondering that. You would think that you would move away from that because Europe is clearly going to get very cold during an Ice Age, just based on the AMOC issue.
Yeah, but the Earth had been in an Ice Age for 100,000 years. So
right.
There was really no difference. They were just moving around, probably looking for more resources.
Right. And you're used to it because that's
resources were slender. And during an Ice Age, during the peak, there is no rain. There's very little weather because it's all dust. And the only place to get fresh water and find animals is on the edge, the margin of the ice sheets.
Yeah.
Where they're melting. Right. So you have to live there.
Yeah.
So it was just a matter of necessity. So the big question is what shuts down the AMOC? And a lot of people speculate it is a Heinrich event will shut down the AMOC. No one knows what these are. These are huge ice rafting events where all this Arctic ice ends up in southern latitudes, like down in South Carolina. No one knows what that is. Another explanation, and an easy one, is the release of the Beaufort Gyre. So a huge freshwater release south into this region where the northern part of the AMOC is, the Greenland Sea and the North Sea up there, could potentially shut the AMOC down.
Right.
Or slow it like a break.
Right.
And so that might be the trigger on what happens, what triggers, they always talk about the tipping point in an ice age. What is it? It could simply be the shutdown of these major ocean currents, which are keeping northern latitudes warm.
Right.
Yeah.
I mean, it's funny because if you you sent me a Washington Post article about the 2024 paper that examined the Florida current. And they, of course, frame it all in terms of anthropogenic global warming. And they talk about, the idea of the AMOC shutting down as being a consequence of a lack of cold water being forced down in depth.
Yeah.
And sort of shutting down the flow that way. But I think you can shut down if you're just talking about water temperature, I suspect that you can shut down the flow in either direction, right? Whether the let's say the water around Greenland is warming or cooling, I think either way you can shut down that flow.
Yeah, by changing the temperature of the ocean.
Yeah. Yeah.
You might be able to,
right now, the Greenland ice sheet has gained quite a lot of mass since last September, as Tony Heller has been posting.
Huge amounts of ice gain on the Greenland ice sheet, and still gaining in the last few weeks during melt season.
Yeah, although it's kind of hitting the peak right now, but it's like 56 billion over the average from, I can't remember what years, 81 to 2010 or something like that.
And we've even shared on the show that a World War II bomber was found that's under 68 feet or meters of ice.
Yeah.
And so there's very little melting on the Greenland ice sheet. It's only building.
Yeah. Yeah. It's like at a record right now for the last 30 or so years.
Yeah.
So, no, maybe 50 years. But anyway.
Well, and in the long-term cycles, if you look at the graph, the bad news is the only thing that can happen now is that we go down, directly down. That happens sometime in the near future.
Yeah.
And I don't mean a human lifetime. Near future for me is geologically could be 1,000 years, could be 5,000. But at some point in the near future, 1 to 5,000 years, we're going straight down.
Yeah.
Back into an ice age.
Yeah.
Yeah.
I think that's inescapable. And I think that the past geological data, the Epica data, especially here, shows that quite clearly.
Yeah, and the reason is we are in ice house in the Quaternary period. Geologic time is here, going back 4.6 billion years on this graph. Most of Earth's history is 10 degrees C warmer than today. And where we're living today is the coldest time geologically on Earth. The last 3.64 million years have been ice age. It only happened one other time, maybe two. Back here in the Ordovician Silurian boundary and during the Carboniferous, were we ever as cold as today? Little geology lesson. All right, here we go. Strange radio pulses detected coming from ice in Antarctica. The unusual radio pulses were detected by the Antarctic Impulsive Transient Antenna, ANITA, a range of instruments flown on balloons high above Antarctica that are designed to detect radio waves from cosmic rays hitting the atmosphere. So right there, it's these radio waves are not coming from an alien base under Antarctica. It says right here, they are detecting radio waves from cosmic rays hitting the atmosphere.
Right.
Look at the size of this antenna. That must be one heck of a balloon. Doesn't that look heavy?
Yeah.
That is crazy. So here's the story. Several years ago, a cosmic particle detector in Antarctica observed a series of unusual radio signals, according to an international research group that includes scientists from Penn State. The strange radio pulses were detected between 2016 and 2018 by NASA's Antarctic Impulsive Transient Antenna, or ANITA. Now, a range of instruments flown on balloons high above Antarctica that are designed to detect radio waves from cosmic rays hitting the atmosphere. And a new study provides additional context to the nearly decade-old results. So this isn't even a new discovery.
No.
It's just something people can glom onto and claim there's aliens in Antarctica or there's something nefarious going on there. There are still people that claim you can't go to Antarctica.
Yeah. Right.
Yet flat earthers were just in Antarctica.
Proving themselves wrong.
Rex just interviews a guy that regularly travels to Antarctica.
Right.
Yeah.
I know someone
go to Antarctica if you got enough money.
Yeah. I know someone that went to Antarctica. Well, I know someone that went through to Antarctica this winter on a building project.
You see, you can go.
You can go. It's true. I mean, you don't want to go there for the winter season. That's because then you're stuck there for the whole winter and it's dark the whole time.
So the goal of ANITA, these giant antennas on a balloon, was to gain insight into distant cosmic events by analyzing signals that reach Earth. Rather than reflecting off the ice, the signals, a form of radio waves, appear to be coming from below the horizon, an orientation that could not be explained by current understanding of particle physics, and may have hinted at a new type of particles or interactions previously unknown to science, the team said at the time. Now, a new study using the Pierre Auger Observatory in Argentina, I don't know why I said it that way, analyzed 15 years of cosmic data to try to make sense of the signals. There's the balloon there about to go up. The team of scientists, including Penn State researchers, recently published their results in the Journal of Physics Review Letters. And so we'll provide you with that paper. Search for the anomalous events detected by ANITA using the Pierre Auger Observatory. The radio waves that we detected nearly a decade ago were at really steep angles, like 30 degrees below the surface of the ice, Stephanie Wiesel said, associate professor of physics, astronomy, and astrophysics that's working on the ANITA team. While the origin of these events is unclear, our new study indicates that such events have not been seen by an experiment with long exposure like the Pierre Auger Observatory. So it does not indicate that there is new physics, but rather more information to add to the story. She explained that by their calculations, the anomalous signal had to pass through and interact with thousands of kilometers of rock before reaching the detector, which should have left the radio signal undetectable because it would have been absorbed in the rock. What are your thoughts there?
I don't know. I'm a little confused about what they mean by. Can you scroll back down again?
Yeah.
They're talking and back up a bit, just below the picture. The steep angles, like 30 degrees below the surface of the ice. I don't know what that means because that doesn't really describe an angle. Do you have an understanding of what she's saying?
They're measuring it from somewhere. Somehow they are determining the trajectory of the radio wave.
Yeah, but I'm having a hard time visualizing what that trajectory is based on the way it was described here, so I don't really know quite what to think about it.
Yeah.
And then when they start talking about, being able to detect these even though there's essentially rock in between, that makes me think there's something wrong with how this is being measured.
Well, we know cosmic rays can go through rock, so they're acting as if they can't, which is bizarre.
Right.
But they're not detecting the cosmic rays. They're detecting the radio waves created by the cosmic rays. And I have no idea what that is.
Well, and then so what is the change in the radio waves after it goes through rock, let's say? Right? So without knowing that, maybe somebody knows that, I don't know that, then how you interpret this is kind of, all over the place.
Right. And them detecting this, it's been a decade now. It might have something to do with the weakening magnetosphere and new interactions happening that we've never seen before.
Right.
Yeah. So that's the only conclusion that I can say.
I mean, I mean, it certainly does raise questions too about, we've talked a number of times about, if the, the magnetic field being sort of like a toroidal shape, right? So this being the North Pole, this being the South Pole, and sort of protecting the hemispheres, but you get a ton of radiation through the North and South poles. So obviously that's part of the picture here. What exactly is happening there? Is some of that being reflected and bounced back? Is it different, like you said, because of the weakened magnetosphere? So
Well,
I don't know.
Here, let me read this. The signals came from below the horizon, suggesting they had passed through thousands of miles of rock before reaching the detector. Now, this is the old data, right? The 10-year-old data.
Mm-hmm.
But the radio waves should have been absorbed by the rock. The
Mm.
ANITA team believed that these anomalous signals could not be explained by the current understanding of particle physics. So that was the first conclusion. They had no idea what was going on.
Mm-hmm.
They should have been absorbed.
Mm-hmm.
Follow-up observations and analysis with other instruments, including one recently conducted by the Pierre Auger Observatory in Argentina, have not been able to find the same signals. Yeah. So it may just very well have been an error in what they're detecting.
Right.
Especially if, go ahead.
Or something has changed in the last decade, but it would have to be very significant for there suddenly to be no signal at all.
Yeah.
And
if it was a true signal, then the first conclusion is true, that our current understanding of particle physics is incorrect.
Well, there's that. And then there's also the problem of if we don't really understand what the end result of our interaction, the Earth's interaction with cosmic rays really is entirely.
Yeah.
Right. Like, I mean, I'm thinking in the context of, we've been hypothesizing within the expanding Earth theory that cosmic rays entering Earth at the poles may have some impact on the size of Earth at the end of the day.
Yeah.
So
and someone was arguing with me on X, the dinosaur conundrum. And they were like, well, if the Earth was smaller, gravity would be greater. And that is not the case.
No.
So if the Earth was half the size that it is now, and you do the math, it's quite simple. Gravity would be 1/2. And that would be if you maintain the same density. So by shrinking the Earth, we're not making it 10 times more dense into a denser ball.
Right.
What occurs is transmutation. And so we are maintaining the same density at every size.
Yeah, I mean, this has always been the big question of expanding Earth is the mass less or has the density changed, right? And I think the answer has to be that the mass has actually changed, which is why the gravity would be half as much with a Earth that's half the size.
Right, especially if you're getting transmuting elements from pure energy entering the planet, all it's going to do is change the size.
Right. Well, and
the majority of our planet, the crust is so thin compared to the globe, okay?
Right.
The majority all the way through is homogeneous.
Yeah.
Like all of the mantle is basically the same stuff.
Right. And then the density is not really going to, it's not going to change, or it's not going to really become less dense. There's so much pressure inside the Earth.
Right.
That I mean, and the density would have to be so dramatically different that it wouldn't even make sense.
Right. You would have to get a new material being formed instead of what's already there, the mantle.
Right.
And so you can easily have dinosaurs, but the Earth has to be half the size and the same density. That's the only way.
Yeah. Isn't it funny that, Einstein came up with E=mc² so long ago, and yet it takes quite a lot to get anybody to entertain the idea that there is actually a process of transmuting energy into matter that's occurring. Yeah. Even though that's what our laws of physics actually say in part.
Yeah, or just more peer-reviewed papers on the dinosaur problem and what would have to be the conditions in order to have dinosaurs. There's very few papers on that. There might not be any.
Well, there probably aren't any because imagine you're you're a scientist in academia and you're like, okay, well, in order for dinosaurs to exist on Earth, the Earth had to be half the size. You are going to get laughed right out of, you're not even going to make it to peer review. There's not going to be anything published on that. Nobody is willing to take that leap because it sounds crazy. But sometimes crazy things are the truth. Yeah. I mean, again, Einstein said E equals mc squared. He wasn't, I don't think he was wrong on that point. He was wrong on some stuff, but not that.
Okay, I'm looking up scholarly articles on dinosaurs and Earth size.
I guarantee every person who's ever published on this will come up with some cockamamie rationalization for why creatures that size could exist on our planet at the size that it is today.
It really isn't. There's nothing. It's
or they're not even going to talk about it.
Yeah, there's some in creation geology.
Sure.
There's no papers, nothing. Yeah.
I mean, as things stand right now, with the conditions on Earth right now, like in order to explain how a giraffe is able to exist on Earth with that insanely long neck, the giraffe apparently has a specially adapted vagus nerve that allows it to have a neck that long and its head up that high. I mean, you can only imagine the amount of work that the heart has to do to pump blood all the way up to that little brain.
Yeah.
You know, it's definitely a specially adapted creature, and compared to the size of a dinosaur, it's going to be minuscule. So, so the conditions on Earth should not have been what they are today. What?
Yeah. All right, we got one more topic we can talk about.
Sure.
Runes found in Canadian wilderness baffle archaeologists.
Mm-hmm.
This is just fascinating. What's fascinating is the perplexing discovery happened completely by chance, according to the CBC. The stone became exposed only after a tree fell near the town of Wawa, not far from Lake Superior. Closer inspection showed that someone had etched 255 runes in a roughly 4 by 5 foot section of the slab. Additionally, they took time to add detailed illustrations of a boat, an additional 16 runic signs, and 14 X markings. So because of the way that this was exposed, you know it's old and you know it's not a hoax.
Mm-hmm.
Yeah.
And that it wasn't like moved there either. It's in situ.
Yeah, it's in situ, yeah. And so this first back alphabet or runes was developed between the 2nd and 8th centuries CE. Yeah,
I mean, there's a bunch of different versions of runes, and they kind of give some of that history there.
So what do you think this means?
Well, I actually agree with the article's conclusion that this was probably carved in the early 19th century by somebody who knew runes.
Yeah.
Because they talk in here about how it's actually a version of the Lord's Prayer, but in runes. And there's I guess a published version of this that I think it says it was published in like 1800 or something.
Say that date again.
1800.
Okay.
Maybe. I might not be remembering that correctly. Let's see. Scroll down a little bit. Yeah. So I mean, they kind of trace who was using this version of runes, and then they also track the actual text, and they sort of determined that it had to be a Swede, and there were Swedes working in this area in the early 1800s, And then somewhere in here it says something about the publication of that Lord's Prayer like this.
Yeah, and not during the 17th century, according to his research. Historical documents confirm that Hudson Bay Company stationed Swedish workers at trading posts across Canada beginning in the 1800s.
Mhm.
And it just so happens that Buren's runic Lord's Prayer was republished during
here
the
it is.
19th century.
Okay.
So that's what we have going on here.
Yeah.
So it's not ancient, but
No.
it's pretty cool.
It's cool. Yeah, it's definitely cool. I was saying that it sort of reminded me a little bit of yesterday. Gregory Little posted something on X about a cuneiform tablet, just like a common cuneiform tablet that was
Yeah.
found in Pennsylvania. And it's not an indication of, people who use cuneiform being in Pennsylvania. It's probably that somebody long ago brought it from Europe to Pennsylvania, and and then it was buried.
Yeah,
So it's like,
there are two Indian chiefs that wore cuneiform tablets on a necklace.
right.
So
That's
they
interesting.
definitely got them from Europeans at some point.
Yeah, yeah. So it's just, it's not an indication of anything like, groundbreaking or wild and crazy, but it's still very cool.
Yeah. Now we have a similar site in Los Lunas, New Mexico here, where someone claims the 10 Commandments. I think they're also written in runes, aren't they?
Oh, no, it's not. Is it runes?
Old Hebrew, something weird.
I can't remember what it's in, but
But
it's
that site is in fact a hoax that was
yeah,
done at the turn of the century.
right.
Right. But maybe it's not a hoax. Maybe it's someone like this person who was religious and wanted to carve it into stone.
Well, it's only a hoax if, like, it could be that the person who put it there, it wasn't a hoax for them, that they just inscribed to this thing because it was important to them.
Yeah.
But, but then you get modern people coming along and they find this thing and then they claim that it's evidence of something far more ancient or far more groundbreaking.
Right. They were claiming that it's the lost tribe of Israel that did it.
Right. And that's the hoax. It's not the actual thing necessarily. It's
Right.
how we interpret it later.
Holy macaroni.
You get to a certain point and it's like, I mean, obviously I'm all for being skeptical and questioning everything, but you can get into this state of mind where your skepticism starts to apply to every single little thing around you until there's no reality for you to even hold on to. I mean, we know some people personally who are like this, and it's a little scary because at some point you're going to lose your mind if you do that. If you have no grounded basis in reality and you think that everything around you is some kind of, hoax or conspiracy, then you're going to lose your mind.
Right. And look into it.
Mhm.
Contempt prior to investigation is what's happening all the time.
Mhm.
It simply means you come to a conclusion without ever looking into any of it. Right. And so
Right.
when people are listening to these figures on the internet say something or show a scientific paper and says it means this, and they don't go look at the paper to see if it means that,
Yeah.
then that's their fault.
Yeah. Yes. I mean, and like you said, a big part of the problem is forming an opinion before you even evaluated the evidence. The best thing you can do is remain completely neutral
Right.
until you've looked into it. And I think you and I both operate that way. I'm sure, all human beings are biased on some level, and in some respect it's inescapable. But you can do your very best to limit your bias by not forming an opinion and staying completely neutral and saying, I don't know. And if you really want to know, go look at the data, go read the sources, look at various analyses and come to a conclusion that way. Right now we have an X platform that is like almost entirely like conspiracy. I took a long break from X several
Well, you
months.
said it. It's engagement farming.
Yes. And I got back on a couple of nights ago and I'm just going through a feed for an hour and a half. And I'm like, this is all engagement farming. There's no longer a dialogue and a discourse going on here that's useful. It's all engagement farming. And the method of engagement farming is to present something that seems really wild and crazy and conspiratorial, and then you draw people in. And you have to consider that too, that you may be being manipulated. Like we talked about in the beginning of this show, there's a particular person who's claiming that a scientific paper reaches a conclusion, which it absolutely does not. And that person is counting on the fact that you are not going to go read the paper. So go read the damn paper if you want to know the truth.
Yeah. And
You
Google
know?
it. Find another paper. Read the sources that the paper came from. It's
Right.
simple to do. You don't have to be a genius. You just ask, give me all the research on this, Grok, and it will.
Right.
It's that simple. So think critically, do your own homework. Don't believe everything you hear on the internet, and be safe. We love you. Great show.